If you're looking for news related to KubeCon Paris, then this episode is for you. Welcome back to the Is It Observable YouTube channel. So today's episode is a bit special. As you can see, we are not in the studio. We are in Paris in KubeCon Europe 2024. Like usual, when I'm KubeCon, I will walk through the venue, look at different booths, try to make some interviews. And also, I saw a couple of great speakers at the Observability day, the first day. So I will have some few speakers that will share their presentations. So follow me in Paris for KubeCon Europe. Let's head to the main train station, close to where I live. And then we have a 4 hours train. And then, of course, traditional metro. First day, collocated event, especially for myself. It's going to be Observability Day, and I'm giving a talk, by the way, so I'm very excited about that, and very excited to meet all the observability community. So let's go for that, and let's prepare and be ready for the conference.
And I'm senior software engineer at Google, and I'm a tech lead for Google Cloud Managed Service for Prometheus. I'm Prometheus maintainer. I maintain Thanos and various other open source projects. I'm active in the CNCF, in tech observability as a tech lead, and yeah, I love optimizations, observability, and I guess go on. I guess it's a unique position right now because usually we had one Prometheus operator. It's literally called Prometheus operator. It's an official project from Red Hat back then, and we kind of wanted to build something which is specialized for collection of metrics, right? Which does it very well, and just you have less configuration knobs. You just start it up and it works. This is why I created Google Managed GMP, let's say, collector. It's fully open source, like you deploy it similarly to you deploy Prometheus operator, but you cannot really configure it to have Prometheuses or any kind of metric collected to be queried directly locally in a Kubernetes cluster, but it rather collect and send away. This allows us to have a very, very smooth and efficient kind of collection auto-scaling deployment model, right? It's based on daemon set. Anyway, that's details. We want to hide that from users. We want for users to only create essentially your scrape configuration, which in our case is pod monitoring instead of like pod monitors, but they're really the same. At the end, you create a certain monitoring configuration which is attached to your applications, which literally you ship together, and it's kind of automatically scrapes and sends to the backend you want, be it Google Cloud monitoring or really any other vendor or Thanos or Tortoise or Prometheus. And it's kind of like more and more users use this collection-only mechanism. So we wanted to really have specialized operator, which is simpler to maintain for everybody and us, simpler to make it secure as well. There are lots of knobs to make sure it's kind of like on scale, ready. And what I'm grateful for and kind of like impressed is that we have that on Google Cloud Kubernetes engine for by default, right? So it's running already for you if you start the cluster, and you just create your script configuration, Pod monitor, custom resource, deploy it, and your data is immediately in Google Cloud Monitoring, and you can configure it to other clouds as well. And what it proves is that we're able to have this operator running, or on every GKE cluster, we have right now, essentially it runs Prometheus per node. So we have over 100,000 Prometheus running around the world right now, which we kind of maintain, and we are on call for that. So it's pretty amazing that, we are able to do this. So we want to share this open source project to others as well.
You mentioned the pod monitor to get the data.
Yeah.
So can I have the similar features to configure scrub configs, relating config, and so on with the pod monitor?
All of this, right? It's fully flexible. It's kind of Google opinionated, I would say. So for example, for initial relabeling, for service discovery, Prometheus gives you full flexibility where you could in theory create some pre-processing that actually tells pod monitoring to scrape actually totally different pod than you selected, right? We want to limit that. We want to really focus on making sure people don't essentially shoot themselves in the foot. So we limit some configuration patterns, so it's more safe to use. But also you have flexibility, on other parts. You have normal relabeling after you scrape the metrics, so you can kind of change the labels. Maybe in future we'll have some, spare scrape recording rules. That's not there in Prometheus, but we are innovating because we are part of Prometheus team. I'm maintaining Prometheus as well. I want my team members also to kind of be more close to Prometheus. They already contribute, so we will be putting a lot of stuff that we learn into Prometheus and learning from each other, which is amazing, which is why I'm excited to be in this team. We are just, pragmatic. In Google, we have an amazing Monarch system, which has pros and cons. It's not perfect, it's very large. You have to have kind of large team to maintain it, right? But it's kind of fast, it's cheap. So at the end, it was just a very easy decision to just use that as our managed solution. So you can totally, send metrics there and use our scalable monitoring, which we use the same kind of team and the same SRE team, the same kind of software to monitor Google infrastructure, our, Google Search and Google Ads and all of those big services around the world. We use the same metric engine, I would say. So you can leverage that as well where you use our cloud. But of course, you can totally deploy on GKE Thanos and solve it on your own. Probably cheaper, right? But you have to maintain your own software. That's also good. I also maintain Thanos. So if you are interested in how to maybe do this with a little bit more open source work, why not? It's all possible. We are adding from this version of GKE, I think 1.29, we are adding default metrics, right? Essentially, if you just start cluster, you already can have cAdvisor metrics, and soon we'll have GPU metrics from NVIDIA, this is GM it's called, and KubeState metrics. So all those amazing open source projects and essentially exporters, we kind of deliver that to you whenever you start cluster, and you have those metrics available in your Google Cloud monitoring straight away. So that's amazing. Or another vendor if you configure. So we want to make sure it's just super no-brainer to just start up and have monitoring ready for you, at least for metrics for now. Soon maybe more signals.
I'm Andrzej Stencel. I live in Poland and I work for Sumo. I work for the OpenTelemetry collector contrib. I'm an approver in the contrib repository. The most used components or receivers used by the community, I would say that is the file log receiver, one of the most used components definitely. It's used for collecting logs in Kubernetes. It's used for collecting logs anywhere else as well. The other component is host metrics receiver, which actually still needs quite a lot of work. There's so many things. This morning, I think I received a question about another metric that the host receiver should actually be collecting. So yeah, still a lot of work in the collector. So the file log receiver is actually used to be a separate application called Stanza, and it was contributed to OpenTelemetry collector, and it does include some components, parts of the Stanza which are not being used in the collector. Stanza is currently only used as a receiver, so all the outputs that Stanza came with are not being used in the collector at all. Also, actually, Stanza used to use its own data model, which is different from the OTLP model. So currently, when you use file log receiver and you add operators inside the file log receiver, it's like processors in OpenTelemetry collector, but they are part of the file log receiver. You can add as many of them as you want, and they operate on the Stanza data model. Only after the processing of all the operators ends, the data is being translated into the OpenTelemetry model and moved on to the actual processors and to the exporters. I believe there's work to be done to clean up the code base so that it's easier for newcomers to understand why this looks this way, why some features are available in file log receiver but not in other receivers, which historically comes down to the fact that this has been part of Stanza and others not. Yeah, we definitely have some refactoring to do. Different plugins do report its own telemetry in different way very often. There's a small library inside of collector which allows, for example, exporters to emit similar metrics, which is great, and I believe we should do more of it. We should standardize. This is still not standardized, but there's been work from Joshua McDonald on standardizing the metrics that the hotel collector emits itself. We need to definitely do more of that and make it easier for other component creators to emit metrics which are standard, which are easy to collect, easy to understand. So if you want to actually trace the collector, it's in the works, which is a little bit funny because the OpenTelemetry collector should be perhaps the most observable binary which is in the world. It's after all I don't think it is at the moment, but there has been some work on that from Alex Boughton, and hopefully there comes soon a time when we are able to collect full traces. OpenTelemetry collector actually is great for tracing because it has the whole pipeline, receivers, processors, exporters. So a trace with so many spans would be very interesting to see where the time is being spent. It's currently, I think, it's in experimental status to be able to export traces from the collector. There's still much work, a lot of work to do, so come and join the project and contribute. If you want to start contributing, I would definitely recommend to start in the contrib repository. There's so much work to do there. There are so many different components. You can just focus on one of the specific components that you may be interested in. Maybe you're interested only in traces. Maybe you're interested only in logs. Just go into that component and try to see what's missing. There are plenty of issues already open. Maybe something comes up in your own usage. Just try to run it and see what doesn't fit you. Maybe there's documentation missing. There's plenty of work to do. I would recommend to start there. As part of my work at Sumo Logic for the OpenTelemetry collector, my job is to make the OpenTelemetry collector the best collector for either logs or metrics or traces for Sumo Logic and for any other user that maybe you want to export your data anywhere else. Sumo Logic has been for quite some time now going heavily in on OpenTelemetry collector. This is our next generation collector. Sumo Logic used to have historically its own proprietary collector, but the future is only OpenTelemetry collector. Sumo Logic has been focusing on logs specifically for the last couple of months. So I would say my focus is also mostly on the file log receiver and being able to collect logs reliably, performantly, and securely.
name's Christopher Nuland. I work at Red Hat, and I'm a technical marketing manager for our OpenShift AI product. The other day I was talking about resource capacity planning using machine learning. My talk was focused on how do we predict how our Kubernetes clusters use things like memory and CPU. This is a really important subject right now, as over-provisioning is a real problem, especially for clusters that run in the cloud. By using machine learning models, I hope to find ways that we can predict different, what we would call localized trends, to be able to better actually do capacity planning for those types of clusters. So things like requests on pods and making sure that like multi-tenancy principles are followed within those types of clusters. To develop this type of model, I use something called a long, short-term memory model. It's called an RNN type of algorithm. And what it does is it looks for trends in a series of data. This is very popular right now. It's the same type of technology that's used for LLMs right now. It's really hyped up in the industry. Those use what are called transformers, which are very similar to an LSTM. Really what we're doing is we're taking a series of data that has, that's in the series trying to predict what's next in the series. In this case, we're looking at memory consumption or CPU consumption and trying to figure out what's tomorrow going to look like for our cluster, what's next week going to look like. And this particular model works really well for predicting things that are close to it. So tomorrow, next week, it starts not doing as well when you're looking at next month or 3 months from now. But for capacity planning, if you're seeing a significant trend, it will allow you to respond to that and not over-provision your cluster. One thing about this particular model that there's an advantage of is that we can use what's called multivariable series model. So the example I gave earlier was a single variable our parameter where we're looking at maybe just CPU or just memory. But this particular model can be used to look at correlations between memory and CPU. Another example I gave in my talk was something called a z-score. This is a statistical number that's used to show the magnitude of how things are changing. And it's often used to find things like erroneous scheduled pods or network issues. And this is where I see the most opportunities in the field right now, where we can start combining some of these different parameters and actually be able to predict not just capacity, but also compare that to erroneous activity within a cluster as well. If people are wanting to get more involved in this area, they can definitely reach out to me on LinkedIn. Another thing is you can look at my GitHub. It's at C Nuland. And that I have, this particular project is titled AI metrics, as I have it in there. And there's opportunities there, but I think there's more opportunities to actually make this into a community as well. So I hope there are some observability and machine learning nerds out there that would love to get with me and actually find ways that we could actually turn some of these concepts more into a community within open source. So some ways that we could have some continuous integration around the model. I think a lot about Kubeflow and some of their pipelines integrations. So Kubeflow is a way that you can interact with a Jupyter notebook and collaborate with others. But there's some other functionality with it too, and one of those is pipelines. That's something that can be triggered at a particular interval, either daily or weekly or whatever you want to configure. And for the type of model that I've been talking about today, it does need to be continually refined, because as new data comes in, new trends are going to start forming. This is where AI ops and ML ops are very critical, because we need to find integrations and ways to have these types of pipelines where we're pulling the data, we're making sure to normalize the data, and then we're training that data into the model, and then finding some way to infer that data by hosting that model in some location. I would just follow my LinkedIn. I post regularly. I do have a blog post that I have in this series where I actually talk about using statistical models instead of machine learning models. If you just search my name and search pod capacity planning, Red Hat blog, you should find my first series. And then I hope to continue that series with this subject around machine learning. I love coming to KubeCon. It's my favorite. It's the thing I look forward to every year, both North America and the Europe versions. I just love connecting with the community. I feel like the people here, they understand what I'm passionate about. At some trade shows, it's business focused, but here everyone's about the creativity and finding unique solutions in the community and working together to solve problems. And it's just really exciting to see machine learning and AI be so prominent this year, because so much of those opportunities are coming to fruition. We're seeing those opportunities, how the community can come together to solve them.
Villela, and I am a senior staff developer advocate at ServiceNow Cloud Observability. And I work in the OpenTelemetry space. That's my primary job function. And I work closely with Reese in the OTel end user working group.
Hi, and I am Reese Lee. I'm a senior developer relations engineer at NewRelic, and I work with the lovely Adriana and Villela on the OpenTelemetry end user community working group.
What?
So the session that we presented yesterday was called "Dude, Where's My Error? How OpenTelemetry records errors and why it doesn't like that." And our talk was about how OpenTelemetry records errors, and we talked about what a span in OpenTelemetry is, the different ways you can use OpenTelemetry to record errors. So you can record errors using spans as span events, or you can use logs.
When it comes to throwing an error or an exception in OTel, because languages like Go don't support exceptions, but like Java and Python do, it becomes really difficult to have that standardization across the board, right? Because now we're not expressing these things in the same way, but we still need to capture the errors and exceptions in our code. But because OpenTelemetry does have that common language for expressing and capturing those errors and exceptions, then we are able to do so. And so the way that they're rendered, like in an observability backend, or even like in your OTel collector, becomes like this really standardized way of doing it.
So in terms of whether it'd be more useful or practical to record errors using logs or spans, the answer is everyone's favorite. It depends. Perhaps your team primarily uses logs, perhaps they primarily use traces. And there's different benefits to both. So marking a span as an error if the operation errors out can make the error stand out and easier to surface. On the other hand, if your system is producing thousands of spans per minute and you're not doing any kind of data filtering or sampling, you might miss errors that aren't occurring very frequently, but that still need to be handled. But the cool thing with OpenTelemetry is it allows logs and trace correlation, so you can actually navigate from like an error log or an error trace to the affected signal and find out more information to help you troubleshoot.
The other thing that's worth mentioning too is like whether or not your backend supports it, right? Because in our demo yesterday, we showed like an example that was capturing errors where the code was actually emitting logs and traces, but one of the backends was Jaeger, and it only captures trace data. Versus then the other two backends that we were demoing in do have that capability of capturing the logs and the traces. So it really is. It becomes a question of like, what's your company comfortable with, and then also what is the capability of your observability backend. What do I expect from KubeCon Europe? I think I expect to like meet up with various people that I've interacted with online in the last, couple of years. So it's a bit of a reunion. It's a bit of a, meet you for the first time. I think opportunities like for networking and learning cool things just from like casual conversations and catching cool sessions.
And as far as like what I expect from KubeCon EU, I mean, a lot of it has already been met. I've got to see a lot of people that I've worked with in the community. A lot of them, seeing again for like the second or third time, which is amazing, and also meeting a lot of new people and learning new things, and just learning about more interesting use cases with OpenTelemetry and learning more about the project because it is so big and there's so many moving parts to it.
My name is Itiel Shwartz, and I'm the CTO of Komodor, and we're a modern Kubernetes management platform. And that means that we help the organization to overcome Kubernetes challenges and its overall complexity. We help the two main personas that are using Kubernetes on a day-to-day basis. On one hand, we have the platform engineers, the people who are responsible for making sure that the Kubernetes runs as expected. The other side is developers. Those people usually lack the proper experience and knowledge around solving Kubernetes issues, and for them, we give a guided troubleshooting experience that promises that they will be able to understand what is happening in their cluster, to understand the impact, and also to remediate issues. So for developer, we give independent and the ability to shift left ownership to them. And on the other side, for cluster operators, we give the ability to manage your cluster if it's the cluster level, cluster upgrades, and so on. If it's around the nodes and their utilization and pattern, and also around the application issues, cost reduction, and policies enforcement. So I'll start doing a short demo on the product. On the main clusters page, we're able to see all of the different clusters across all of the different regions. If it's hybrid, if it's in multiple different clouds, you're able to see everything within Komodor in an aggregated way. And inside the screen, we have both the real-time status, meaning how is the system currently behaving, but also issues and problems over time around three main pillars: reliability, policies, and around cost. Once I'm going to click on a specific cluster here, I will be able to see, first of all, again, all of the real-time metrics, but also reliability, policies, and cost score. And this cluster has really low scores around all of them. And it means that it is much more error-prone. What an error will happen, it's going to be much more severe. And also, it means that it's not configured according to best practice. When I'm talking about policies, we are talking about mainly security policy, operational policies, and custom policies the organization provides. And in Komodor, you can enforce the best practices out of the box to ensure that all of the different clusters are working properly. Security, operation, and custom policies. As well, for the cost part, in Komodor, we believe no application developer or cluster owner knows what are the right requests or limits. And in Komodor, we have the ability to do right sizing for your application. And that means that we have an autopilot that allows you to make sure that your applications are running smoothly and efficiently. The way that we give our recommendation is like a very smart algorithm that we develop internally that looks both at the last 14 days, but also at the last 48 hours. So it's a combination, and it ensures that, again, on one hand, your cost is insane, but on the other hand, we don't hurt the performance of your application. Now I want to jump very quickly to show what Komodor provides for developers. And developers usually don't really have a lot of context around Kubernetes troubleshooting, and yet they outnumber platform engineers 10 to 1 or even 20 to 1. And with Komodor, you have the ability to configure their RBAC, their authentication, everything that you need in order to trust them on one hand, but also give them the relevant tools in order to solve issues by themselves. And in Komodor, we have here the timeline of a specific service, and that means how did this service change over the last 24 hours. And this includes things like alerts from Datadog or Dynatrace, PagerDuty or OpsGenie, but also things like deploys and availability issues. For example, I can click here and see a deploy that failed. I'm able to see exactly why did it fail, at the logs, the snapshot of the logs, but also all of the things that change as part of this deployment, everything in one single place. So your developers will be able to solve it without going to 5 different tools and escalate it to the DevOps. And I'm able to see exactly the changes that happen. Last thing that I want to show is the Komodor guided troubleshooting experience. This is basically taking a developer hand in hand around solving the issues without needing to escalate. So once I click on the investigate, I have different steps that I'm taking in order to solve the problem. I'm able to see the network mapping, meaning how did this application interact with other applications. I'm able to see the logs of the application. But more than that, we know that developers sometimes are not sure how to approach the logs. So we have integration with OpenAI in an effort to simplify the root cause finding even more. And in here, we are able to see both root cause and possible solution, and this is thanks to Komodor plus OpenAI integration. And we see here the problem is our API rate limit, which is a variable that is larger than the max acceptable size. I can now click and see exactly what changed before the issue happened, and we know all of the issues are, or most of the issues originate from changes. But more than that, a developer will now be able also to do a rollback for that specific service. And that basically means that you are able to give the developers all of the tooling needed in order to investigate and diagnose the issue, but also to solve it. Everything you see here can be also audited. You can give the right permission to the right people. So Komodor, in a high level, it's everything your organization needs to overcome the challenges of Kubernetes. We're great for organizations that are multi-cloud or multi-region, but also for organizations that are just now starting their Kubernetes migration story. The way Komodor collects all of its data is using an agent, like a proprietary agent. We have a very low footprint. It's very easy installation, 5 minutes, and you have Komodor already installed on top of all of your clusters. So the installation is very easy, and we send only very small portion of the data. We work great with existing APM like Datadog, Dynatrace, NewRelic, and also Grafana and so on.
OpenFeature. Biggest update is our recent enhancements to our specification to really better support client-side feature flagging. So practically that means more robust semantics around events and also around caching. We actually, we just released those, but kind of somewhat related. We released our 1.0 web SDK, which is a big deal because that's going to be the SDK that all of our React, Angular, and framework-specific SDKs are based on. So it's been a long time coming. The client is really important for feature flags. Really, before we were focused on feature flagging in the server, and what the client specification enhancements and the specification around a static context specifically is allowing us to do is focus more on client-side use cases. So yeah, the web for sure, mobile apps as well. Well, actually, the OpenFeature operator is definitely compatible with the web SDKs. What it requires is the FlagD web provider. So we're going to be making a number of enhancements to the FlagD web provider, so that if you're running a FlagD in your infrastructure, that can communicate all the way with the front end. So it's not so much changes to FlagD itself as changes to the bits of code that connect to FlagD. So bits of code that would support iOS, Android, and right now what we've been working on a lot of is web. So that you can talk to a FlagD that's been exposed over your infrastructure via HTTP and use it in the front end. So what we're kind of recommending is that in most cases you do run FlagD as a sidecar or sometimes in process, but for the purposes of the web, yeah, we kind of recommend that you deploy a FlagD as more of a standalone instance and then expose that via a service with an ingress or a gateway API, and then the clients, that will be basically like a purpose deployed FlagD instance just for serving UI requests. That's the idea.
And the FlagD evaluation will be done with WebSocket or?
Yeah, it's actually done with Connect protocol. So Connect is basically like gRPC over HTTP 1.1. So essentially, you can use gRPC from web clients, but you have all the benefits of gRPC, including like robust protobuf, small message sizes, and server-sent events and streaming. Yeah, that's something we're thinking about doing. Yeah, so we're thinking that there may be like a specific CRD just for the web, but right now, because you don't have to inject it into a workload, our thinking is you probably just deploy this manually, but we are considering a specific operator feature. Yeah, I think like we're going to wait for kind of usage and users to give us feedback about that specifically. But at the very least, right now, we're going to have like a standalone flag D, a recommended architecture done that way. Actually, we have a couple blog posts recently on OpenFeature.dev specifically talking about our efforts with the static context paradigm with the client SDK, basically. And stay tuned because we're going to be starting a blog on flagd.dev as well, and we'll talk more about the flag D implications that you've asked about. Yeah, you have cores to worry about. You have CSP to worry about. You have definitely a different threat environment in the web, and we're aware of that. So we're going to be providing some recommendations for that as well.
My name is Oleg Nenashev. I'm a CNCF ambassador. I'm working on a few projects related mostly to the observability space, and I'm a Jenkins core maintainer, and all my journey is about developer tools. Yesterday I did an Ignite presentation about observability with Gradle. So basically my talk was about what happens next after you have observability configured for your CI/CD system. You have a lot of tools under the hood, and for all of them you need to have some insights so that you can store a full trace. You need spans from different tools like compilers, static analyzers, synthesizers, etc. And basically this talk was about that. So going beyond just CI/CD and connecting build tools to the observability domain. Speaking about continuous integration and continuous delivery, all modern tools have integrations with OpenTelemetry to some extent. In Jenkins, there is OpenTelemetry plugin. There are native integrations in tools like Dagger, Argo CD, and they submit all the information from their side. But under the hood, they invoke other tools. So Jenkins itself doesn't build your project. It will be Gradle or Maven. If you do Java project, it will be Golang tooling set. If you build a Golang project, and these tools need to submit OpenTelemetry spans, logs, and metrics too, if you want to have full insights about what happens during your build process. In the continuous delivery space, there is no standard way to do reporting. Yes, there is OpenTelemetry, which we use to standardize on. But OpenTelemetry is not enough to do all CI or CD observability because it's just traces, metrics, logs. Yes, now we expect to have more data sources. But for example, for events, we have to use cloud events mostly. And there are other open specifications like CD events, which are currently being explored as a way to deliver events happening in the system. And there is ongoing proposal in OpenTelemetry to make CD events also a substandard within OpenTelemetry to deliver events from CI and CD systems to the OpenTelemetry and observability tools like Prometheus, Jaeger, or other platforms. In the future, we want whole CI/CD pipelines to be unified. So for standard events, like the package is built, the package is deployed, test completed, etc., we would have a unified set of metrics. And then if you connect a standard tool to your observability system, you can extract this information using this open specification. So a good example is how unit tests are happening at the moment. They have unified format. So whether you build a Golang project or Java or C++ project, you get approximately the same format. And we want it to be for all the events. So for example, if you have your own developer portal, for example, based on Backstage, on Grafana or other tool, if they query your observability system using the standard format, they will be automatically able to retrieve tests, etc., from your system without any customization. If you're interested in this initiative, there are multiple channels available. The major one is CI/CD Observability Special Interest Group, which is now a part of the OpenTelemetry project. So if you go on the CNCF Slack, there is OTEL-CICD channel. where we have all these discussions, and I already shared my presentation from yesterday about Gradle and OpenTelemetry specifically. For other projects, so for example, in Java space, Gradle has a developer productivity engineering channel where you can also join and discuss all matters on Java build flow observability, for example, with Shwartz, with Gradle, with Maven, or with other tools. We maintain this channel specifically for the Java ecosystem and for its use cases. This week, my main expectation from KubeCon is meeting people and having discussions. I participate in many cloud-native projects, for example, OpenFeature, Microx, OpenTelemetry, and my interest to meet the community, to have discussions. Also, I meet many of my previous colleagues from the CNCF space and discuss some potential collaborations, partnerships, especially on the observability space.
That's it for today's episode related to KubeCon Europe. As you can see, I think it was really excited to hear about the GMP operator from Google. I think it's very interesting to see that they are providing their own CRD about Prometheus. I really like the approach of shared on the Red Hat booth about the way of doing predictive on metrics and try to do auto scaling based on that. So it's really interesting. And again, there's all the solutions that we talked about. So if you have any interested on any of the solution that was presented or any more details about one of the talks, drop in the comment below and we'll try to make a deep dive on it. So thank you for watching, and if you enjoyed that episode, don't forget to like and subscribe to the channel. See you soon for another episode. Bye.